When we're writing an inequality notation, we're showing a range of numbers. So x is greater than 5 is showing the range of numbers that are greater than 5. So we've started at 5 and then we're going to numbers greater than them. So another way to show this range of numbers that I graphed is with interval notation. So notice in interval notation, I'm showing that I started at 5, so 5 comes first, and then I'm going forever to numbers bigger than 5. So this could be like 10. So it's going all the way out to positive infinity. So the way I write this in interval notation is I say it's going from 5 to positive infinity. With x is less than or equal to 2, I'd be starting at 2. I'd have my solid dot. And then if x is smaller than 2, I'd be going to numbers smaller than 2. So my arrow would be going forever to the left. So now, since it's going forever to small numbers, it's going out to negative infinity, because eventually we'd hit negative numbers. So when I do my interval notation, I go from left to right. So from the left, I'm going to negative infinity. And then when I go to the right, the farthest I can hit is 2. So in interval notation, I've got negative infinity to 2. So notice the difference between these two, or one difference, is the type of bracket. So here I use this square bracket to show that I'm including the 2, and here I use the parenthesis to show that I'm not including the 5. Infinity and negative infinity go on forever, so you can never include them, so they're both going to have that parenthesis to show that you can't include them. So to summarize that, a square bracket is used to include the end value, so here we included the 2, and then a round bracket is used to exclude the end value. If you don't want to call it a round bracket, you can call it a parenthesis, but those are used to exclude the end value, so you're not going to include the 5. So to write the following inequalities in interval notation, sometimes it helps me to actually draw them out for myself. So if I'm seeing x is greater than or equal to 3, I've got 3, I've got a solid dot, and then it's greater than 3. So I know I've started at 3 on the left, and I'm going forever to infinity. So to write that in interval notation, I'm including the 3, and then I'm going forever to infinity. And you can't include infinity, so you've got a parenthesis. X is less than negative 2. So if you don't want to draw it, you could just think if x is less than 2, we're starting with numbers smaller than negative 2, and we can't include that. And then the farthest number we can hit is negative 2. And there's no equals to, so we're going to do a parenthesis instead of a bracket. This last one's a little tricky. We've never seen anything like this before. It's saying x is greater than or equal to 2, and x is less than or equal to 10. So this is something we're going to deal with during our lessons this week. So we've got our 2, and we've got 10, and this time x is in the middle of them. They both have an equals to, so they're both going to be a solid dot. And since x exists between them, I've got my values in between those two is where I've shaded. So in interval notation, we're including the 2, because that's on the left, and we're including the 10, because that's on the right, and both of them are going to get that square bracket. The other type of special interval notation you're going to see are all real numbers. So for all real numbers, instead of doing that fancy R, in interval notation, all real numbers means we're graphing every single number on the number line. So it's going to go forever to the left and forever to the right. So we've got negative infinity to positive infinity. No solution is a little bit different. It's called the empty set. So normally we do that like circle with a line through it. But an empty set is actually going to use its own even type of bracket. It's going to use the squiggly brackets and just a space in between them to show this empty set. I probably won't use that a lot in our practice problems, but if you go on Delta Math and we do some of our online practice problems, you'll see those squiggly brackets. So why don't you guys try some examples and see what you can do with it.